क्वेश्चन सिमिलर है. Yesterday we solved maximum speed whenever the vehicle along the curve road, and today we have to study expression for minimum possible speed whenever the vehicle is along the curve bank road. So tell me, what is the definition of angle of banking? कोणी पण एक जण. हर्षवर्धन, angle of banking. Okay, the angle between horizontal surface and road surface. तुम्ही आन्सर देणार, मी डायग्राम ड्रॉ करत जाईल. कॉन्शियसली बोर्डकडे लक्ष पाहिजे. The angle between horizontal surface and road surface. Now this is the horizontal surface. And this is the road surface. What we call that inclination, that is angle of banking. Next we consider the vehicle. Consider the vehicle having mass m. So let m equal to what? Mass of the vehicle. Very good. After that, whenever it is moving along the curve bank road, so there is a radius. So what is meant by r? Radius of, very good, radius of curvature. After that, theta. Theta means angle of banking. And last one, V minimum. What about the V minimum? That is the minimum speed whenever the vehicle is along the curve bank road. Simple. For maximum, what is the observation? We make the component that is add into n cos theta, n sin theta. Remember. So for minimize the velocity, what we have to do? That is the component exactly act into the opposite to the n sin theta. So therefore it becomes subtraction. So therefore centripetal force becomes minimum, and in that case mass and radius are same. So therefore only what reduces? Speed. So after draw the diagram, you will understood properly. So first, how many forces act on the object? First is weight. So that is weight. It is denoted by letter W is equal to mg. First force, that is weight, mg, which is act vertically downward. Second one, normal reaction. What is the statement regarding the normal reaction? Normal reaction denoted by letter n. Now it is act upward. It is resolved into two components. What are the two components? Horizontal component and vertical component. So that is horizontal component. And next one, vertical component. So what is the horizontal component? N sin theta. So n be the hypotenuse, theta be the angle of banking, and now this is the adjacent side. For adjacent side, which component is there? That is n cos of theta, and for opposite, that is n sin theta. But we resolve all forces at the point, so therefore we show the direction of, that is horizontal component of normal reaction. इथपर्यंत perfect झालंय. Next, what we have to introduce? Very good. Static frictional force. So the static frictional force is act along the inclination, and remember the direction is upward. So third number force, that is statics frictional force. It is denoted by letter Fs. It is again resolved into two components. What is the first component? That is horizontal, and second is vertical component. So that is horizontal component, and next one is so what is the horizontal component? So very simple, we have to resolve This is the frictional force. बोर्ड कडे प्रॉपरली लक्ष द्या. This is the frictional force F. It is resolved into two components. First is horizontal and next is vertical, and this is the angle theta. So what is the this is side of adjacent or opposite? Adjacent side. So it becomes Fs cos of theta, and it becomes Fs sin of theta. So we complete the all observation. दोन important part complete केला आपण. Part number first, all notations. What is the first notation? Let m be the mass of the vehicle. Second number, radius of curvature. After that, angle of banking. And last one, minimum speed when the vehicle is along the bank road. And after that, we draw the diagram. How many forces act on that vehicle? So there are the various forces. So we first consider that is weight, which is act vertically downward. Second, normal reaction upward, resolve into two component, horizontal component and vertical. What is the horizontal component? N sine of theta, and vertical component n cos of theta. After that, what is the static frictional force? It is the frictional force between tires and road surface along the inclinations upward. Along the inclinations upward. It is resolved into two components. So what is the horizontal component? Fs cos of theta. Derivation बोलायचं आहे. Next, Fs sin of theta. तर हे important. इथपर्यंत लक्षात घ्या. Derivation complete. After that, there are the two important statements regarding the two equations. The statement number first regarding the weight mg and statement number second centripetal force. कोण बोलेल statement? First statement बोलायचं आहे about weight and second about centripetal force. त्याच्यावरती दोन इक्वेशन भेटतील. And after that two equation we know that how to solve, taking ratio, cancel mass and then replace Fs by mu s n and then divide numerator and denominator by n cos theta and sin by cos tan, and after that taking the square root of both sides, that next side, so we get the final answer. So we complete the most important steps, that is the three steps you have to remember. First one, so write down the all notations, that is m for mass of the vehicle, then r for the radius of curvature, theta for angle of banking, and after that v for that is minimum possible speed along the curvature road. Next, after that we have to write down all the various forces act on the object. The first one is the weight, which is act vertically downward. Second is normal reaction, and third one is static frictional force. So last one we already write down that. So that is mv square upon r is equal to n sin theta minus fs cos theta, and then mg, which is balances by the n cos theta and fs sin theta. So next we go for the complete the derivation. So derivation is very easy. So that is mv square upon r is equal to, and then mg equal to. So mv square upon r is equal to what? So that is n sin theta minus fs cos of theta, and after that, so mg means that is n cos theta plus fs sin of theta. Make equation first and then equation second. So on dividing equation first by second, we get mv square upon r divided by mg is equal to, so that is n sin theta minus fs cos of theta on divided by n cos of theta plus fs sin of theta, so is equal to. So very simple question. On both sides what happen, mm get cancel, is equal to, we have to substitute the frictional force. Frictional force is equal to mu s into n. So after substitute the frictional force, so then what we get, n sin theta minus replace the mu s by coefficient of static friction multiplied by normal reaction. So what we get, that is fs So what we get, that is mu s n cos of theta on divided by, that is n cos theta plus mu s n sin of theta. So after that, on dividing, so very simple है, क्या करना है हमें, by dividing, on dividing numerator and denominator by n cos of theta. So we get, after cancelling the mass, we get that is v square by rg is equal to, so that is n sin theta minus mu s n cos theta divided by n cos of theta. After that, n cos of theta plus mu s n sin theta on divided by n cos theta. So separately divide करना, और after separately divide, so that is we get, so now here sin by cos, that is tan, and n get cancelled, so it becomes tan theta, then minus sin, so cos and cos theta get cancelled, so what we get only, that is mu s on divided by, so now here n cos theta get cancelled, so 1 plus mu s tan of theta. So we get, that is v equal to under root of r g tan theta minus mu s divided by 1 plus mu s into tan of theta. So this is the derivation, this is the expression of minimum velocity, that is minimum safe velocity due to which the vehicle take the turn along the curved road. The equation is very important. So we complete the today we complete the all formulas of velocity whenever the vehicle taking the turn. So remember the notes, most important notes. The notes is important for JEE, NEET and CET examinations. So there are the four formulas we complete. First is V equal to under root of mu rg. Second formula is, that is V equal to under root of rg tan of theta. Third formula is, that is V maximum is equal to under root of rg tan theta plus mu s divided by 1 minus mu s tan of theta. And last one formula is, that is fourth number formula, V minimum. Already we saw the derivation 2 days. So that is rg tan theta minus mu s divided by 1 plus mu s tan of theta. So bracket completes. But there are the four formulas where we use the formulas. So according to, you have to remember the some keywords. So according to that, you definitely find out which formula we use. That is, remember the keywords. So first formula use only when the vehicle is taking the curve, the vehicle is taking the turn along the curve road, that is horizontal. Whenever the coefficient of friction is mentioned, that is coefficient of static friction. Next formula we use whenever the angle of banking is given, that is there is an inclination between the road surface and horizontal surface. So that is whenever the angle of banking is given, in this case use the formula number second. And also we can calculate the angle of banking, that is tan inverse of, remember this is most important formula, V square divided by rg. Next formula V max and V minimum. Now there is a clearly mentioned, that is the maximum speed limit or minimum speed limit. And most importantly, there is the value of angle of banking of mu s, both are given, that is theta also given and mu s also given. So according to that, you can find out the speed whenever the vehicle is taking the turn along the curve. You can find out the speed whenever the vehicle is taking the turn along the curve road. So in such way that we complete the today's topic, most important topic. Remember the derivations. So yesterday we already completed the derivation for maximum speed. Today we complete the derivation for minimum speed. So in such way that at the home, just go through practice, read the complete derivation. After that, try to remember, write down the practice so you can get properly. So